All right, today we're going to start chapter 3, section 1. Now comes the process of which we move away just from linear equations. Now we're going to build up to larger, higher order polynomials that, just have multiple vertices, multiple x-intercepts. This is where we start deviating from all that stuff. Section 1 deals with what are called complex numbers. Before we get into complex numbers, before I fully define them, let's first look at what caused it to exist. For example, everybody knows what square root of 4 is. I hope. It's 2. Square root of 36 is what? 6. Square root of 8. What's that? Let's see how we got that. First off, what number, invisible number, is there in that V? No, what number? Because if it was a cube root, we'd have a 3 there. If it was a 5th root, we'd have a 5 there. So what number would that one be? 2. It's invisible 2. The reason that's important is because this is called the root. R-O-O-T. It's called the root. That's why it's called the square root. This one here with a 3 is called a cube root. This one's called a 5th root. So what is 4 made up of? 2 times 2. We have a pair of 2's, which is exactly what the square root tells us. We need a pair of numbers, the same numbers, to take them out of the radical. 36. To do it the long way. 36 is made up of 6 times 6, 2 times 3, 2 times 3. This process here, what I'm doing with these arrows, is called prime factorization. It's called prime factorization. What that means is I'm taking that number I'm dealing with and breaking it down to its prime numbers. Prime numbers are numbers that can only be divided by 1 and itself. Prime numbers only divisible by 1 and itself. Those are prime numbers. So let's go back to this thing. So 36 is 6 times 6, 2 times 3, 2 times 3. Remember, it's a square root, so we need 2 of a kind. There's 2 2's, so we take out a 2. There are 2 3's, so we take out a 3. 2 times 3 is 6. So that's mathematically what's going on. Same thing here with 8. What is 8 made up of? Yeah, 2 times 4, 4 times 3. 2's as far as you can go there. What can 4 break down? 2 times 2. Remember, it's a square root. Once we have a pair, that pair disappears and goes out in front. Whatever's left goes inside. Take some pens. Yeah, the purple ones are gone. I'm sorry. So that's how you get, if you have an odd number of factors, that's what happens. You have each pair that comes out in front Whatever's left goes inside. If we had cube root of 8, again, 8 is made up of 2 times 2 times 2. We just worked that out up here. What does this 3 tell us? Yeah, we need 3 of a kind to take out of the radical. Since we have 3 2's, it comes out. There's nothing left, so there's nothing in my radical. So that's how you simplify radicals. All right. Another way you could do it. This is a rule that we'll be using in this class in the very near future. The square root of x times y. If you have a product of 2 numbers, you can split them up and take the product of their individual radicals. So let's look at the 8 again. Square root of 8. We know square root of 8 is 4 times 2. We look for perfect squares. So we have square root of 4 times the square root of 2. Those are our 2 numbers inside there. Square root of 4 is 2. So there are multiple ways you can do it. But we'll be using this in the very near future. So everybody's okay with radicals now? Kind of. Just takes practice. But let's take it one step further. Square root of negative 4. What's the answer? Two times 2 is 4, not negative 4. Negative 2 times negative 2 is positive 4. Because whatever it is has to be the same number. In order to take it out of the radical, has to be exactly the same number. That little negative there is causing a problem. So we have to get rid of it. Whenever you have a negative inside an even root, in other words, if this is a 2, 4, 6, 8, some even number. If you have an even root, if you have a negative inside there, take out the negative and put an I there. So that negative comes out, becomes an I. Square root of 4 is 2, so your answer is 2i. I stands for an imaginary number. Can anybody guess what the value of I is? No, can't be, because we just took from this to that. No, you're closer to infinity. What do we do? What is this really taking out? What kind of one? Negative one, very good. So an I, whenever you see that, that represents the square root of -1. Well, how's that? Remember the last rule I just gave you about x times y equals radical x times radical y? -4 is actually a product of -1 times 4. So because of that, I can split these up. Now, because of this association there, anywhere you see a square root of -1, we put an I in its place. The square root of 4 is 2. The answer is 2y. We've actually seen this part earlier. When it says -4, it's not really one number, it's two numbers. Are these equal? Yes or no? No, they're not equal. ¿Por qué no? Yes, this one in parentheses, that negative stays with the 2. So negative times negative is positive, 2 times 2 is 4. So if the negative is inside the parentheses raised to a power, even power, it's positive. But this one, order of operation, says we have to do exponents first, not multiplication, because this is -1 times 2. So this one is -2 times 2, which is -4, which means they're not equal. We talked about this about 3 or 4 weeks ago. Look at your notes, and this is where everything connects with everything else in this course. So now we have I introduced, which now comes to our definition of complex numbers. A complex number looks like this. A plus BI. A is a real number. BI is the imaginary number. So that could be anything. This takes care of everything in the number world. If it's not just real, it's real and imaginary. For example, tell me if this is a complex number or not. Complex or not? Yes or no? It is a complex number. Remember, A and B could be any numbers. Isn't that a complex number? B is 0. So if B is 0, we just have that number. So every number we have is a complex number. For I, that's a complex number. The real number part is 0. or it could have something like this. Let me see. There. Or it could have something like that. An imaginary and real part. So every number we have is a complex number. It's just whether A and or B are solid numbers or zeros. So far, so good. Now let's talk about the algebra of complex numbers. I'll do that in a minute. When we say algebra of a number, what are we talking about? Algebra of complex numbers. And instead of writing complex numbers from now on, I'm only going to write CN. Whenever we hear the word algebra of, all that means is we can do any of those. Add, subtract, multiply, or divide. Oh, let's see. Adding and subtracting CNs. Actually, we've been doing it all along. What is that? Yeah, -2 plus 5 is bigger than 3. It's negative. Subtract the numbers. So we've been doing it all along. But let's look at it this way. 2 plus 5i plus -6 plus 2i. Order of operations says do what first? What's inside the parentheses? Can we combine these two? No, they're not like terms. So we get rid of the parenthesis. If there's nothing in front, we just drop the parentheses. What's really happening, I can't just, I don't feel good saying just drop the parentheses. I'll show you why I want to do subtraction. What's really happening is every coefficient, if there's nothing there, is automatically a 1. 1 times 2 is 2. 1 times 5 is 5i. So same thing there, same thing here. 1 times positive times negative is negative. 1 times 6 is 6. Positive times positive is positive. 1 times 2i is 2i. Whenever you get rid of parentheses, you always do what next? Combine like terms. Whenever you get rid of parentheses, always combine like terms. The real parts. 2 minus 6. Opposite signs. So the sign of the larger is negative. 6 minus 2 is 4. Then the imaginary part. 5 plus 2, they're both positive, so it's 7i. There's your answer. 4 plus 7i. Three minus 4i minus 5 plus 6i. You're This is an example why I don't like just drop the parentheses. You can't just drop the parentheses. What's in front of here? There's 1. 1 times 3 is 3. Positive times negative is negative. 1 times 4i is 4i. Notice these numbers here are both positive. That negative in front actually changes everybody's sign. Negative times positive is negative. 1 times 5 is 5. Negative times positive is negative. 1 times 6 is 6i. So you see, from 5 plus 6i, it's now -5, -6i. So distribute instead of just dropping the parentheses. What's my next step? Combine like terms. The real numbers. 3 minus 5i. Yeah, so 5 is bigger than 3, it's negative. 5 minus 3 is 2. The imaginaries, they're both negative, so the answer is negative. 6 plus 4 is 10. I. There's your answer. You don't always have to have just 2 numbers. Here we have 3 CNs. But they have coefficients. Go ahead, do this one first. Finished? Okay, what'd you get? Well, I mean, whatever you got on your page, let's see. It could be right, it could be wrong. Yeah, you have to distribute first, yes. So let's see what happens here. Negative times negative is what? Positive. 2 times 3 is 6. Negative times positive is a negative. 2 times 2 is 4. I. Because the I has to stay there. Positive times positive is positive. 3 times 2 is 6. Positive times positive is positive. 3 times 5 is 15i. Because this is 5 times I. So it's 3 times 5 times I, which is 15i. Negative times positive is a negative. 5 times 2 is 10. Negative and a negative is a positive. 5 times 3 times I is 15I. That's the first hurdle. Now we combine like terms. 6 plus 6 minus 10. 6 plus 6 is what? 12 minus 10? 2. So that takes care of the real numbers. And we have these last. Remember, by commutativity and associativity, I could do whatever two numbers I want to first. Since I have 3 of them, I could pick whatever two. I'm going to do 15 plus 15 is what? 30 minus 4. 26I. And there's your answer. What'd you get wrong? You're off by 2. It's imaginary. Your imagination is just not there yet. Is everybody okay with this so far? With addition, subtraction? Now let's do multiplication. Multiplication of complex numbers, CNs. The method we're going to use, you may be familiar with. FOIL method. Everybody hear that? If not, let's look at it. So we have 2 plus 3I times 5 plus 2I. FOIL method only works if you have 2 binomials. Binomials are equations that only have 2 terms. So this one has 2 terms, this one has 2 terms. That's the only time FOIL works. What's really happening is everything in this first parenthesis has to multiply to everything in the second parenthesis. So we're going to have first 4 different answers. There's 2 here times 2 here. It's going to be 4 different answers. Let's see. Let's look at this first one. 2 times 5 is 10. Positive and positive is positive. 2 times 2 is 4I. There's nothing else for that one, so that one's finished. Now I do the next number, the positive 3. Positive times positive is positive. 3 times 5 is 15. I. Positive times positive is positive. 3 times 2 is 6. I times I is I squared. We're 1, 2, 3, 4. We have 2 times 2, we should have 4 answers right now. We got rid of parentheses, so let's get combined like terms. These are the only like terms we have so far. Positive 4 plus positive 15, they're both positive. 15 plus 4 is 19. Plus 6I squared. We're not done yet. Whenever you deal with complex numbers, I should never have an exponent. I can never be raised to a power in the final answer. Have we seen I squared before? Not yet, but we're going to figure out what it means. We know that I equals the square root of -1, right? That's the general rule. What happens if we square both sides? Exactly, it gets rid of the square root. So I squared is equal to -1. There we have another rule. So anywhere you see an I squared, just replace that I squared with a -1. So it's 6 times -1. So we have 10 plus 19i. Positive times negative is a negative. 6 times 1 is 6. We got rid of the parentheses, so we have to combine like terms. 10 minus 6 is 4 minus 19i. The answer has to remain a complex number, which is a plus bi. You can't have any more than that. There cannot be any exponents on the I or anything like that. Let's work this one out. Once everybody feels comfortable with doing all these, we'll do some other more tricky ones. That's not a good sign. We've only been here half an hour. You're looking at your watches already. All right. So let's look at the first number, the 5. Yeah. Positive times negative is negative. 5 times 2 is 10. The next one, positive times negative is negative. 5 times 4 times I. 5 times 4 is 20. I. This I'm going to show you another way of doing this next part. It'll make it easier for you. So negative times negative is a positive. 3 times 2 is 6. I. If you line up on top of each other, it makes it much easier so you know exactly what has to be simplified. Negative times negative is a positive. 3 times 4 is 12. I times I is I squared. So now we just add straight down. So negative 10. Negative 20 plus 6. 20 is bigger, so the answer is negative. 20 minus 6 is 14i. Plus 12i squared is -1. So we have -10 minus 14i. Positive times negative is negative. So negative 10 minus 12. They're both negatives. 12 plus 10. 22 minus 14i. So what's the purpose of I squared? What does it really do? It changes the sign of its coefficient. Plus a positive 12 I squared eventually becomes negative 12. So if you have an I squared, just get rid of it, change the sign of the number in front of it. That's all it really does. Everybody okay with this? Okay, let's do some more tricky ones. My battery is running low. Let's look at this one. Finished already? No, you're just braiding your hair. Did you get that? So let's see what happens. 3 times 3 is 9. Positive times negative is negative. 3 times 4 is 12i. Positive times positive is positive. 4 times 3 is 12i. Positive times negative is negative. 4 times 4 is 16. I times I is I squared. Obviously, the 12s cancel. They're same numbers, different signs. This I squared just changes that to a plus. So we have 9 plus 16 is 25. Negative 1 plus 5i times negative 1 minus 5i. Good job. All right, let's see if this happens. So the first one, negative times negative is a positive. 1 times 1 is 1. Negative times negative is a positive. 1 times 5 is 5i. Positive times negative is a negative. 5 times 1 is 5i. Positive times negative is negative. 5 times 5 is 25. I times I is I squared. The 5s cancel. This I squared changes the sign of the number in front of it. So it becomes 1 plus 25 equals 26. One more, and then I'll explain to you what's really happening here. 5 minus 6i. 5 plus 6i. And so 5 minus 6i times 5 plus 6i. Right, step by step. Positive times positive is a positive. 5 times 5 is 25. Positive times positive is positive. 5 times 6 is 30i. Negative times positive is negative. 6 times 5 is 30i. Negative times positive is negative. 6 times 6 is 36. I squared. The 30s cancel. So we have 25 minus 36 I squared. The I squared just changes that sign to a plus. So we get 61. There. With these type of equations, I want you just to be able to look at them. You have 7 plus 2i, 7 minus 2i, and tell me what the answer is. This is a special type of equation. Yeah, I appreciate you all working on these, but I'm gonna show you a shortcut in a minute. Give me any two numbers. Any two numbers. That's 10 and what else? Okay. 10 plus 4i, 10 minus 4i. Two numbers. The answer is 116. This type of equation is called a complex conjugate. A complex conjugate is simply where you change the sign in front of the imaginary term. A complex conjugate is where you just change the sign in front of the imaginary term. So if I gave you a plus bi, what's the complex conjugate? A minus bi. All I did was change the sign. Whenever you do that, your answer is simply going to be a squared plus b squared. Because the i's in the middle cancel, I squared becomes -1. So this is what always happens. So if you have the same numbers, just only thing different is the signs in front of the i's, then we just do the shortcut. Let's look at our examples. 3, this one here. What's 3 squared? 9. What's 4 squared? 16. 16 plus 9 is 25. 1 squared? 5 squared? 25 plus 1? 26. 5 squared? 6 squared? 25 plus 36? 61. So that's a shortcut. So yeah, we could do the whole FOIL thing if you want to, but if you have two numbers that the only thing changes are the signs, we could just look at 7 squared plus 2 squared. 49 plus 4 is 53. Now, there's got to be a reason for this to be in math in the first place. There is. We've talked about adding, subtracting. We've talked about multiplying. What's the last one? Division of complex numbers. The process of dividing complex numbers only has one basic rule. You cannot have an imaginary number on the bottom. That's the basic rule. So if you do have an I on the bottom, we have to get rid of it. We have two types. Monomial denominators What's a monomial? One what? Nomial, one number. A monomial denominator, because you have a numerator over a denominator. The denominator is the bottom number. If the bottom, it's only one term, that's a monomial denominator. Only one term on the bottom. It's an imaginary term. Remember, we cannot have i's on the bottom. How do you get rid of that I? Multiply it by what? Multiply it by I over I. What is I divided by I? Anything divided by itself is 1. So all I'm doing is multiplying by 1. I'm just not changing the number. I'm changing the way it looks. So we have 2 times I, 3 times I squared. I squared is -1. So your final answer is -2i over 3. So if you have an I on the bottom, just multiply top and bottom by I and gets rid of it. Let's try another one. Important point, negatives are never really supposed to be on the bottom. So if you have a negative on the bottom, either put it with the top number or put it in front of the entire equation. Just get it off the bottom. What if I had this? Well, it'll make a -4i, -4 over 5i. -4 over 5i. So multiply top and bottom by I. So -4i over 5i squared. All the I squared does is change the sign of the number in front of it. -4i over -5. Negatives cancel. So you have 4i over 5. So basically, if you have an I on the bottom, all it really does is change the sign of the entire question to begin with. From 2 over 3i to 2i over 3, -2i over 3. 4 over 5i, negative, is positive 4i over 5. Okay, you can have imaginary equations on top, binomials. But because the bottom number is the important one, what do we multiply to this one? Because we have a monomial on the bottom. If you have a monomial and has imaginary, then multiply the top and bottom by I. So it becomes 2i plus 3i squared over 5i squared what's that? What I? It's not a, look at a blimp. It's an imaginary number. Open up your mind. Yeah, it's a 3i squared. So it's 2i minus 3 over negative 3. Who got 2i as the final answer? Good. That'd be wrong. You cannot cancel these negative 3i's because this is one number, has to stay together. So this negative sign comes up here and just changes all those signs. So it's negative 2i plus 3 and it's just housekeeping from there. Both of these are correct. It's just that the bottom one looks more correct because imaginary numbers is a plus bi. So whenever you have a negative on the bottom, change everybody's sign on top. That gets rid of it. Okay, I give it one more, then we'll do the next part. All right, go there. You're still processing it because I see what's going through your head. You're the only one that's gotten it correct so far. You should be done because there's no I on the bottom. It's as far as it goes. So, yeah, if there's no I on the bottom, you don't have to simplify anything. Only if you have, you cannot have an I on the bottom. That's as far as you can go. Now, the second type, if you have binomial denominators, in other words, if your bottom number looks like this, it's a complex number. So if your bottom number, if your denominator is a binomial, imaginary number, complex number, in other words, we can't have I on the bottom. So what do we multiply by to get rid of the bottom I? The conjugate. That's the whole reason we learned the conjugate, is because when we multiply those two together, all we did is change the sign in front of the I. Whenever you do that, all the imaginaries disappear. So if you have an imaginary term on the bottom, multiply by its conjugate, top and bottom. And if you know if you remember the shortcut, use that. It's 4 and 5. Don't worry about the signs. They all cancel out. It's just 4A plus B. So distribute that one. We get 4 times 3 is 12. 3 times 5 is 15I. 16 plus 25 is 41. And there's your answer. Let's try another one. So what's the conjugate? Yeah. 3 plus 2I. All I have to do is change the sign in front of the I term. So the bottom is going to be 3 squared plus 2 squared. And the top is negative 2 times 3 is negative 6. Positive times negative is negative 4I. Negative 6 minus 4I. 9 plus 4 is 13. There's your answer. Everybody getting those right so far? Anybody not getting them right? Let's see what's going on. Because right now I've been giving you some easy pitches because the top numbers is a monomial. Let's have a binomial on top. Yeah, please. What's the conjugate? 3 minus 4i, because we only care about the bottom. Because you cannot have an I on the bottom. That's one we have to get rid of. So change that sign on the bottom. We know the bottom. The only real trouble you'll have is on the top number. You have to do the foiling there. 5 times 3. Positive times negative is negative. 5 times 4 is 20. Negative times positive is negative. 3 times 2 is 6. Negative, negative is a positive. 2 times 4 is 8. I times I is I squared. This I squared, all it does is change the sign of that positive to a negative. So we have 15 minus 8 is 7. Negative 20 minus 6 is negative 26i. 3 squared is 9. 9 plus 16 is 25. There's your answer. What's the difficult part there? Or if there's one? I mean, if you see it straightforward, great. But if you're having a little bit of trouble, where are you having trouble at? Want to do another one? Everybody okay? One more? There. Negative 3 plus 5i divided by negative 2 minus 7i. So before you get too far, what's the conjugate? What are you multiplying by? Negative 2 plus 7i. Negative 2 plus 7i. Because that's the only sign you change, the one in front of the I. Don't change anything else. That should be your first step. This is where I need to know if you have any troubles. I need to know because I can keep on going. If I don't hear any objections, I'm gonna keep on going. But right now I'm looking at a deer in headlights. Which one? The conjugate? Yeah, so whatever the bottom number is, whatever's in front of the I, change that. Everything else is the same. -2 minus plus 7i. So once you have that, then you know the shortcut is just this. Take the first number, positive or negative, just take the number, square it. Second number, square it, and that's the bottom number. So that should be just the wave of the hand part. The hard part should be on the very top. We do more moving parts. Negative times negative is a positive. 2 times 3 is 6. Negative times positive is a negative. 7 times 3 is 21i. Positive times negative is negative. 5 times 2 is 10i. Positive times positive is positive. 7 times 5 is 35i squared. All the I squared does is change that sign. So it's now a minus. So we have 6 minus 21i minus 10i minus 35 over 53. Combine like terms. 6 minus 35. 35 is bigger, so the answer is negative. 35 minus 6 is 29. Negative 21 minus 10. They're both negative. 21 plus 10 is 31i over 53. All right, so that's that part. We've done addition, subtraction, multiplication, division. I even show you the shortcut for do the bottom part. You don't have to do the FOIL part there. The last topic we have to talk about, remember I said earlier, I cannot have an exponent in the final answer. That is a rule. So if I gave you I to 35, what would you do? Let's look to solve this. Let's look at the pattern. We have I. Then we had I squared. What does I squared equal? It's I times I, yes, but that equals -1. So anywhere you see an I squared, you put a -1. I'm glad you said I times I, because what's I cubed? I cubed is I squared times I. Well, we know I squared is -1 times I, so it's -I. So I cubed is the same thing as -I. I to the 4th is I cubed times I. Well, what's I cubed? I cubed was -I times I. -I times I is -I squared. But what's I squared? I squared is -1. Negative of -1 is +1. Let's do a couple more, and I'll show you the pattern. I to the 5th is I to the 4th times I. You see what we're doing? Each step, we're just multiplying by another I. I to the 4th is 1. 1 times I is I. I to the 6th is I to the 5th times I. Well, I to the 5th is I. So I times I is I squared, and that equals -1. I promise 2 more steps and I'm done. I to the 7th is I to the 6th times I. I to the 6th is -1 times I is -I. And I to the 8th is I to the 7th times I. So -I times I is -I squared. -I squared is the same thing as 1. So I squared is -1. Negative of negative is a +1. I'm sorry. There. My fat old head's in the way. So everybody follow that so far. Let me put the summary right here. These are the 8 that we did. So I is I squared is -1, I cubed was -I to the 4th was +1, I to the 5th was I to the 6th was -1, I to the 7th was -I, y to the 8th was 1. This is what's called modeling. We put down a whole bunch of sequences and see what happens from there. Is there a pattern? Is there a pattern? Yeah. It's, if you notice, they repeat in groups of 4. I, -1, -I, 1. So basically, the easiest way to remember that, this pattern is, if you won a race that you never thought you'd win, what would you yell? I won, I won. I won, I won. Middle two are negative. That's the easiest way to memorize that sequence. But now, what does that do? Since they happen in groups of 4, whatever number we have up here, divide it by 4. $35 divided by 4. How many times? Well, 9 times 4 is 36, right? So it's not 9. It's got to be 8. 8 times 4 is 32. How many left over is there? There's 3 left over. There's a remainder of 3. Because 8 times 4 is 32. And between 32 and 35 is 3. Subtract those 2. So if the remainder is 1, your answer is I. If your remainder is 2, your answer is -1. If your remainder is 3, it's -I. If you don't have a remainder, your answer is 1. So I to the 35th power. Since the remainder is 3, it equals -I. And there's your answer. Because remember, your answer, your imaginary, could either be positive or negative, 1 or I. Can't have any exponents. So those are the only possibilities you have. These are the only 4. Well, yeah, once we did, yeah, we only do this once, so we see a pattern. I could have just told you this, but you wouldn't understand why. Whenever you see a pattern of numbers, that's why I divided by 4. If this happened in groups of 6, I'd divide by 6. And the remainders would be 1, 2, 3, 4, 5, 0. So try what you just learned. I to the 97th power. When you finish, this will be your exit ticket for your break. Yep, that's it. Yes.